day, class. So, for our meeting today, I'm going to tackle staining, mounting, and the different histopathologic faults that you would encounter when processing tissues. Now, let's start with staining, class. Now, staining, as you're all aware, is the process of applying dyes on the section to see and study the architectural pattern of the tissue and their physical characteristics of the cells. Now, this is very important, class, for pathologists to identify if there are abnormalities in the structure on a cellular level when it comes to the sample being processed. Now, staining categories. Now, there are three. We have the first one. We have the first one, the histological category. Now, these are stains that would have components demonstrated by direct interaction with a dye or staining solution, usually used for nucleus and cytoplasm. Active tissue component is colored. Microanatomical stains, bacterial stains, and specific tissue stains are such. Example of the stains class would include gram stain, acid fast stain, right stain, methylene blue, carbolfuchsin, and crystal violet. Now, the second staining category is the histochemical or the histochemistry. Now, here tissue components are studied through chemical reaction for demonstration of chemical components such as your Pearl's Prussian blue for hemoglobin and your PAS for carbohydrates. Then the last category is the immunohistochemical staining used to demonstrate tissue antigen. This is usually used class for identifying specific types of viruses and fungi, and in some cases also could be used parasitology parasitology. Now, this is a combination of immunologic and histochemical staining. It uses antibodies that is either polyclonal or monoclonal. Detection of phenotypic markers are detected by antibodies. Now, what are the different staining techniques? The first one would be direct staining. Uses aqueous or alcoholic dye solutions to produce a color. Usually only one dye and the color of the dye is the resulting color. So in direct staining class, you have here your sample or your tissue plus the dye. The, the sample or the tissue would absorb the dye, producing a color. A very good example of this is methylene blue. Then we have your indirect staining. So in indirect staining, it uses a mordant or accentuator. Here we have the tissue plus the dye plus the mordant or accentuator. Now, what is a mordant or accentuator class? A mordant class serves as a link or bridge between the dye and the tissue. While your accentuator, it increases the color intensity and selectivity of the dye. Example of this is KOH in Loeffler's methylene blue and phenol in carbolfuchsin and carbol-thionine. Then another staining technique class is progressive staining. This is wherein gradual application of the dye is done. Tissue elements are stained in a definite sequence. Dye is applied little by little until the desired color is achieved. Tissue will not be overstained. No excess dye, no decolorization. So take note of that. Now the fourth one is regressive staining. So the tissue is first overstained and excess dye is removed through decolorization. Now with excess dye, decolorization or differentiation is known as the selective removal of excess dye. Commonly used is acid alcohol. Can remove both acid and basic dye. Now take note of this rule, class. To remove excess acid dye, you have to use a basic solution. While to remove excess basic dye, you need to use an acidic solution. Then another staining technique is counter staining. Involves application of a different color to produce contrast and background. Example of this is you use here two or more types of stains, class. Example is eosin, which is a red acid dye used for cytoplasm, class. Thus, eosin is a cytoplasmic stain. While basic component naman, class, would be acid dye, and acid component would use a basic dye. So if the component of a cell, class, is basic or alkaline, the dye used should be acidic. But if the component of the cell is acidic, or the part of the cell is acidic, you have to use a basic dye. Forms example is eosin Y, which would produce yellowish, eosin B, bluish, ethyl eosin or eosin S. Then another staining technique is the metachromatic staining. This stains tissues with a color that is different from the stain itself. So if the color of the stain is blue, class, and you apply it to the tissue, it would there's a possibility that it could become red or brown. Example of this, class, is methyl violet or crystal violet, crescel blue for reticulocyte, safranin, Bismarck brown, basic fuchsin, methylene blue, thionin, toluidine blue, Assure A, B, and C. Then another one is your orthochromatic staining. So tissue is stained with the same shade or hue as of the dye. Another one is vital staining. So vital staining would usually involve the demonstration of living cells, cells that are basically viable or fresh. Under vital staining, we have intravital. Now, when you say intravital, the dye or stain is injected to any part of the living body. Example is lithium, carmine, India ink. And another one under vital staining is supravital. Stain is immediately applied to tissue after its removal from the living body. Ang pinaka magandang example dito, class, is in your hematology, your new methylene blue, which was used for reticulocyte. Now, other example would be neutral red, which is considered the best vital stain. Janus green for mitochondria, trypan blue, Nile blue, thionin, and toluidine blue. Then we also have metallic impregnation. So it does not use dyes. For metallic impregnation, dyes are not used. Instead, you would use metallic salts. Tissue elements are demonstrated not by stains but by colorless solution of metallic salts, leaving black deposits on the surface of the tissue. Example is ammoniacal silver, silver nitrate, and gold chloride. Now, in histopath, class, the routine stain use is your HNE, or the hematoxylin and eosin staining. So this is the most common method used for microanatomical studies of tissue. This is a regressive staining method. It uses decolorization reagents. So you would start here in HAA staining. You would have used an initial silane bath. This is used for further deparaffinization. Then you would use descending grades of alcohol for hydration, hematoxylin for dehydration. Then for hematoxylin, which is the primary dye, nuclear dye, and basic dye. Then you would use acid alcohol, which would act as a decolorizer, ammonia water, which is a bluing agent, intensifying the color of the nucleus. Then you would use a counter stain, yung eosin glass, which would be an acid dye for cytoplasmic staining. Then you would use ascending grades of alcohol for dehydration. Sorry, so dapat pala hydration to, class. Sorry. Then last, silane blot for clearing prior to mounting. So this is the actual process. So here you would use for silane 3 minutes, then another silane for 3 minutes. Then you would use descending grades of alcohol for hydration. Then you would use the primary dye, hematoxylin, which is for your nucleus. Then you would use ammonia water, which would intensify the color of the nucleus. Eosin, which is the counter stain for cytoplasmic stain. Then you now use the ascending grades of alcohol for dehydration. Then last silane baths. Take for 5 minutes each for clearing. So the HNA result class, this is the expected result after performing. The nucleus should appear blue to black. Karyosome should appear dark blue. Cytoplasm should appear pale pink. RBCs, eosinophilic granules, keratin should appear orange red. Then calcium and decalcified bone should appear purplish blue. Decalcified bone matrix, collagen, and osteoid would appear pink. Muscle fibers would appear deep pink. So take note of the results. Now, staining methods for frozen section class would include the following: H&E, thionine, polychrome methylene blue, alcoholic pinacyanol. Now, let's talk about the different dyes. Now, dyes are categorized class into natural and synthetic. Let's start first with the natural dyes. Now, natural dyes class are derived from plants and animals, such as hematoxylin, coccineal dyes, orcine, and saffron. Let's start first with hematoxylin, since this is the one commonly used. Now, hematoxylin is technically classed not a stain. Instead, hematoxylin contains what we call an active coloring agent known as your hematin. Now, this is formed from the oxidation of hematoxylin either by exposure to sunlight, ripening, or by adding oxidizing agents. Now, what are these oxidizing agents? This would include hydrogen peroxide, mercuric peroxide, sodium iodate, sodium perborate, and potassium permanganate in combination with alum, iron, chromium, and copper salts. So let's continue. Now, the most common example or variation of hematoxylin use class is the alum hematoxylin. Uses potassium alum as a mordant. So we have here Ehrlich's hematoxylin, which would use sodium iodate as a ripening agent. Harris hematoxylin, mercuric oxide for exfoliative cytology and demonstration of sex chromosome. Cole's hematoxylin, which uses alcoholic iodine. Mayer's hematoxylin, which uses sodium iodate with citric acid and chloral hydrate as preservative for immunohistochemistry. Then we have Delafield's, uses glycerol as a stabilizing agent for the oxidation process. Smells like wine and gives purple red shade. Then we have your Gills. This uses sodium iodate to stain mucin in goblet cells. And Karasi, which uses potassium iodate. Then we have iron hematoxylin. So this is generally used for photomicrography. Uses iron as a mordant. So we have Weigert's hematoxylin used for muscle fibers and connective tissue. Mordant use class is ferric ammonium chloride. Then we have Heidenhain's hematoxylin for nuclei and cytoplasmic inclusion, such as the mitochondria. Mordant use is the ferric ammonium sulfate. Then we have copper hematoxylin, demonstrates spermatogenesis. Tungsten hematoxylin uses phosphotungstic acid as mordant. Then we have lead hematoxylin, demonstration of granules of endocrine cells of the alimentary tract. Then we have molybdenum hematoxylin, demonstration of collagen, reticulin, and argentaphene cells. Now, other examples of natural dye class is the coccineal dye. Now, this is extracted from a bug treated with alum to produce carmine. Here, you would use picric acid forming picrocarmine. Si picrocarmine class is used for neuropathological studies. Then we have using carmine with aluminum chloride, you would form best carmine. Best carmine is used for glycogen. Then we have Orcine class, another natural dye. This is a vegetable dye extracted from lichens, used for staining elastic fiber. Litmus class is a vegetable dye extracted from lichens but is not used as a cytological stain. Now let's go to the last group of dyes class, yung synthetic dyes, also known as the coal tar dyes or the aniline dyes. Now it has what we call a chromophore. Now the chromophore class is responsible for the coloring property of the dye. Then it also has an oxochrome responsible for the dyeing property, which is refers to the retention of the color. Now, another variation of the synthetic dyes are the lysochrome dyes or the oil-soluble dyes. These are synthetic dyes class without oxochrome component. It is usually used for demonstration of fats, such as Sudan Black B, which is the most sensitive of the oil-soluble dyes. Sudan 4, also known as your Charlock, for neutral lipids, staining them red. And Sudan 3, which is the first Sudan dye introduced into histochemistry. It is considered a good fat stain for CNS tissue. Now, very important, usually asked in board exam class is the special stains. So, I'm not gonna tackle them one by one. I'm just gonna choose some of the stains. So they are categorized based on the substance or tissue sample they stain. The first one is the carbohydrates. So a good example here, class, is the best carmine nyo for glycogen, mast cell granules, fibrin, mucin. Another example is the mucicarmine stain used for mucins. So all of this class are used for staining carbohydrates, glycogen, mast cells, fibrin, mucin. So kindly memorize them. Another one is for protein. We have your Sakaguchi's test, usually used for arginine. Then staining of fats or lipids rather, sorry. We have that stain Sudan black. Now under Sudan black, we have Sudan 4 or Sherlock R for lipids, mainly triglyceride. Then we also have your BHPS or the borohydride periodic shift for gangliosides. Then stains for enzyme are also used. Example of this is your Gomori lead method, which is used for ACP, and Gomori calcium used for ALP. Then we also have stain for bone marrow and blood elements such as your Reich's Gemsa, peroxidase reaction for myeloid. Then for connective tissue, we have your Von Gison for collagen. Then metal violet or crystal violet method, which are used for amyloid. Then for nucleic acid class, we have methyl green pyronine method for both RNA and DNA. For muscle and bone, we have your Hayden-Heinz iron hematoxylin used for muscle, striations, mitochondria, myelin, and chromatin. Then for the CNS, we have Bodjan stain for nerve fibers, nerve endings, neuretic plaques, and so on. Also, another example here is Wales method for the CNS. Stain used for myelin sheaths. Then we also have stain for tissue pigments and deposit class. A good example here is your Gomoris aldehyde fuchsin, which is used for lipofuscin. Maloris fuchsin for hemofuchsin pigment, as well as von Cosa's silver nitrate method for calcium demonstration. Now, the special stains class could also be used for staining microorganism. A common example here is the oramin rhodamine fluorescent method used for mycobacteria and the Dieterle method used for Legionella pneumophila and your Grocott metamine silver for fungi. So kindly memorize all of these special stains class. They will come out in your quiz and exam. Here's our Here are additional stains that would be important class. A good example here is yung modified Steiner method nyo, used for filamentous and non-filamentous bacteria, and your modified Palmgrens used for nerve fibers in paraffin embedded material. Now let's go to the mounting now, class. Now mounting is also known as cover slipping. So once you've had your tissue process, you now cut them and place them here. Now what stained na sila, now you would add a cover slip. Now this is the process of applying a mounting medium between the stained tissue section and the cover slip. This is for permanent safekeeping and to facilitate easy handling and storage, and also to prevent bleaching of the section. Now, the mounting medium, class, please take note, should have a refractive index or yung tinatawag nating clearness close to that of the slide, which is 1.518. So take note of the refractive index 1.518. Now let's talk about the types of mountant. We have the resinous mountant used for preparations that have been dehydrated and cleared in saline. This is considered a permanent mountant. Example here is Canada balsam, which has a refractive index of 1.524, extracted from Abus balsamea. This is the one commonly used. Disadvantage, class, is that it darkens with age and causes gradual fading of many stain. Other examples of resinous mountant are your DPX with a refractive index of 1.532, XAM which has a refractive index of 1.52, and Clarite which has a refractive index of 0.544. Another type of mountant is the aqueous mountant, used to mount water miscible preparations, semi-permanent and temporary mountant. Example is your glycerin jelly, also known as your Kaiser, has a refractive index of 1.47. Farans, also known as gum arabic, refractive index of 1.43. Apatis for methylene blue stain nerve preparation has a refractive index of 1.52. Now, for mounting frozen sections directly from water glass, the recommended mountant is bronze fluid. Water is never used in the practice. Now, the disadvantage of aqueous mountant glass is that it tends to have low refractive index and would evaporate easily, thus not allowing the examination of tissues under OIO. Now, other things you have to consider, class, is ringing and labeling. Ringing is not a mandatory step in tissue processing, class. It seals the margin in the cover slip, used to prevent escape of fluid, prevent sticking of slides, immobilize the cover slip. Example of substance used in ringing, class, is chronic cement and Durofix. Labeling, class, indicates the year and specimen number for proper identification. So in labeling, the slide include the year, the specimen number for proper identification. So in some, we could light it 24, then 001. Or if it's in the year 2022, you could write 002. Now let's go to the last topic. So here is the most tedious class, also asked in the board exam. Again, I won't explain them one by one, but here you would be able to find faults, the reason or the cause of the fault, and the remedy. So if the sections fail to form ribbons, class, this is most likely due to surface and edges of the block not parallel. So to fix this, you need to retrim the block. Then for horizontal surface of the block not parallel to the knife, you need to readjust and orient the block. Paraffin wax is too hard, you need to coat horizontal edges of the block. Then if the sections are wrinkled or jammed or compressed, knife is blunt or dull. To remedy this, you need to sharpen the knife. Too rapid cutting, you need to decrease cutting speed for every thin section. Now, if the sections naman, class, would tend to adhere to the knife or other parts of the microtome, this could be caused by static electricity. So to remedy this, you need to breathe out or blow gently on the block and knife to break up static. If the knife edge is dirty, it could also cause this problem, class. So you need to clean the knife. Other possible faults reason for sections adhering to the knife is that the knife edge is dull, tilt of the knife is too great. So sharpen the knife or reduce the tilt. Then we also have resistance is felt on the lower part of the section during cutting. So tilt of the knife is too small. Paraffin block is therefore compressed against the base of the knife towards the end of the stroke. To remedy this, increase the tilt. Then sections cut is sometimes thin or sometimes thick. This could be caused plus by knife being too blunt. So it's recommended to sharpen the knife. Then pleated, folded, and crooked ribbons is usually caused by imperfections in the blade edge, such as horizontal edges. So to remedy this, trim the block parallel to the other edge or re-embed them in molds. Then brittle or hard tissue could be caused by a problem in the processing, prolonged fixation, prolonged dehydration. So tissue may be softened by soaking in a small dish or bowl containing water with detergent, phenol, or Molliflex. Then on trimming wax, they would appear crystalline. So this could be caused by contaminated wax re-embed in a freshly filtered wax. Then, if there is a hard, dense tissue, tough keratin component of certain tissues. So to remedy this class, treat fixed tissues using 4% aqueous phenol for 24 to 72 hours to soften. So that ends the entire lesson class for staining, mounting, and faults. Kindly memorize the tables. Thank you.